So hello, everyone. My name is Robert Smith, and this is Ben Tucker. We are program managers on the Windows Embedded Standard team, and today we are talking to you about new developer tools and Windows Embedded Standard 2011. Go ahead. So today we're going to learn a little bit about the Windows Embedded Standard 2011 toolkit, how you build images based on Windows Embedded Standard, which is the Windows 7-based version of our embedded products. We're going to learn how to customize an OS so that it just meets the needs of your applications. We wanted to let you know our beta, our CTP, which is our equivalent of a beta, is available now. And you can go to windowsembedded.com and check that out. A little bit of logistics. I'm going to go through a quick overview of what exactly Windows Embedded Standard 2011 is. Then we're going to go straight into demos. I'm going to go and do an overview of the wizard-like experience of the toolkit, and then Ben is going to go and show the advanced configuration that you can do. So with that, we'll get started. So how many of you are familiar with Windows Embedded at all? All right, how about the differences between Windows Embedded Standard and Windows Embedded CE or Compact? About the same. All right, cool. So Windows Embedded Compact is kind of a more consumer-oriented operating system. It runs on things like GPSs, little handheld devices. Windows Embedded Standard runs on things like ATMs, cash registers, thin clients, martini mixers, jukeboxes, things like that. And then finally, we have the Ready family of products, including Windows Embedded Pause Ready, which is kind of an easy way to get started for the point-of-sale devices like cash registers. So why exactly would you use Windows Embedded Standard 2011? What it is we take Windows 7 and we break it down into hundreds of packages. Then you're allowed to build the OS from the ground up with only the features that you need. So you've got the full compatibility of your standard Windows 7 applications. You can use the typical .NET libraries or just the Win32 APIs. You can use your standard x86 and x64 drivers and just build the operating system that meets the needs of your application, but stripped down so that you don't have the bloat of things like Windows Media Player or Media Center and the things that you wouldn't need on your typical embedded device. We have support for the typical Windows servicing and management tools like Windows PE, WDS, SCCM, those things. And then we also have embedded enabling features, which are add-ons that make your embedded device, or make the operating system more compatible for your embedded device. I'll go into those later. And I mentioned some of the sample devices: kiosk, thin client, point of sale, industrial automation like robots, gaming, medical imaging like CAT scan machines, DVRs, those sort of things. So the toolkit is divided up into two main experiences. We have the wizard experience, which is the tool is called Image Builder Wizard, or IBW, and that it's based on Windows setup. So essentially, you pop in a DVD which contains IBW, and that's just like Windows setup. Pop it in, it boots up. You select the options that you want for your image, like the feature packages like Internet Explorer and things like that. It'll detect the devices on your hardware, and you'll just install. And then the advanced experience is called Image Configuration Editor, or ICE, and that lets you do more advanced editing, such as setting OS settings or adding third-party applications and that sort of thing. And then we're also based on the standard OPK tools. So we have support for DISM, if you know what that is. It's a servicing, command line servicing utility. Windows PE, WDS, those sort of things. Thanks. So this is kind of the main components of the operating system. On the left there, we have the embedded core. And what that is the minimal bootable OS. So it has the servicing stack, it has the networking stack, and a command shell, but not much else. It'll boot, and it can run small applications like Notepad and stuff like that, but it's pretty tiny. On top of that, if you want more functionality, you can add things like Internet Explorer or .NET or DirectX. WPF, those sort of things, to build up the operating system that meets the needs of your application. And then you can also add language packages. We're shooting for compatibility or on parity with full Win7, so like the 47 or so languages they're shipping. Driver packs, you only include the drivers that are needed for your device, so that condenses the OS considerably. Then, like I said earlier, we have the embedded enabling feature packages. So some examples for these are things like write filters. We have an enhanced write filter, which essentially it'll take any writes that would typically go to your disk and just shoot them to a RAM overlay. And so then whenever you restart the device, it's back in its clean, untouched state. We also have a dialog filter, which will block up any pop-ups so that you don't get warning messages on your digital sign in the airport. You can boot off of USB. So those are some examples of EIFs. And then in addition to that, you can add your own third-party applications and OS updates, and then you build. Next. So this is the image building process. On the top, we have the wizard-based experience. There's, like I mentioned, IBW. It's on a DVD. You boot up. IBW will detect the devices on your computer, and it will add only the drivers for the specific hardware that's on your device. You can then select feature packages, language packages, EIFs, and then it gets built directly to your device. The more advanced experience, the image configuration editor, you will analyze the hardware on your device using a separate application called Target Analyzer. That will spit out a .pmq file, which you import into image configuration editor, and it'll add all of your drivers. Once you've added the drivers, you can add, just like in IBW, you can add the feature packages and EIFs and languages that you need. And then once you're done configuring your image, that saves it out to an XML file. Bring that XML file into IBW, and it's called an unattend file. So it just essentially answers all the questions that you would face in IBW and automatically spits out an image to your device. So that is how the image building process works. And now we're going to go and show you the wizard experience. So this is IBW. I mentioned that it boots off a DVD. It'll also boot off a USB disk. So essentially, any way you can get bootable media onto your device, it'll boot up and you can go. So once you get into IBW, the first screen you get to is what I call the template or from scratch screen. So essentially, you can select a template as a starting point, or you can just go from a blank image and build it from the bottom up. So for the purposes of PDC, we're going to select my super cool PDC-09 template. And what's in there, you ask? You can click View Template and see. So in this case, I added some browser. Oh, I added the browser. I added IE8. I think I added DirectX as well, just some minimal stuff. So we're going to use that as a starting point and go with that. So Ben's going to click Next, and here we go. So after we've selected a template or from scratch, the first thing we do is select the language. In this case, I'm OK with English. So since we started from a template, we wanted to make this experience as simple as possible. So you've selected your template, you selected your language, and now you're brought to a summary screen. So if you wanted to, you could just click Next, and you'd be brought to the disk selection screen, and you could just install. But personally, I'm not too happy with this template because it's pretty small, pretty minimal. So what we can do is add drivers and add feature packages to it. So at the top, you can see there's an inbox drivers node. And what that is we analyzed the hardware on your device, and we added the inbox drivers for it. So you can see I'm running this on my laptop, so it's got some Bluetooth and a whole bunch of other devices. There's also an unmapped devices folder. And what that is devices that we detected on your hardware, but we don't have drivers for. So an example for that, if you scroll down a little bit, Ben. So you can see the touch chip fingerprint controller. So I've got a fingerprint reader on my laptop, and unfortunately, we don't have that device in Win 7. So I'll go through later and show you how to add the driver for that. So for that, since I'm not happy with my hardware, I'm going to click Modify Drivers. And then also, if you scroll down a bit, Ben, we can view the feature packages in my template. Like I said earlier, it's pretty minimal, so I'm not happy with that either. So I'm going to select Modify Features as well. And we'll click Next. So because we selected Modify Drivers, we have these 3 options. At the bottom, it's Do Not Select Drivers. So in case I really don't care about my hardware at all, I can just select Do Not Select Additional Drivers, and that will include only the minimal set of drivers so that your operating system can boot. If I ran the Target Analyzer program on a different computer, I can import the PMQ file here and use those drivers. Or I can just select Automatically Detect Devices, and we'll go back to where we were before. So we're going to go with Automatically Detect and click Next. So here's the unmapped devices. Like I mentioned earlier, we can add the third-party drivers here. So I can click the Browse button over there and just point to a folder of INFs, and it'll choose those. So in this case, I don't have my driver on hand, so we're just going to cancel out of that and continue with the drivers we have. So because we clicked Modify Features on the summary screen, we're brought to this page, which has the features in our image that were also in the template. So if you expand the feature package selection node, you can see that some of these features are pre-selected because we started from a template, and then some of them are not. So Ben, if you want to scroll down to, I believe, the security category, I want my device to be a bit more secure, so we're going to add BitLocker. I believe it's, yes, BitLocker Secure Startup. So after we've added packages, you can see the footprint jumps up a little bit. If you want, Ben, if you want to click on and off there, you can see it jumps up like 8 megabytes or so. Once we've added packages, what we do in Windows Embedded is we determine which packages are necessary for the package you selected to work. So essentially, like if you added Internet Explorer, that 50 megabyte file or 50 megabyte package won't exactly work unless you included some other packages. So what we do is we resolve dependencies, and that brings in all of the packages that are necessary for your feature to work. We have things called optional and required dependencies. So the example that we like to use is help is an optional dependency of Internet Explorer. You can use Internet Explorer just fine without help, but you might need it and you might not. So in this case, I don't want the optional dependencies, so I'm going to uncheck that, and we're going to click Resolve, and the footprint will go up a little bit because we added, because BitLocker needed a few things. So I'm happy with this. We're going to click Next, and we're brought to a final summary screen. If I want to change any of this stuff now, I should go back. If not, we're going to go on and install. And finally, we are brought to this disk selection screen. It should be familiar to any of you who have installed Windows before. Select a partition, format, install. Because this is running on my laptop, we're going to not install. But that's about it. So now I'm going to shoot it over to Ben, and he's going to give you the advanced tour of Windows Embedded.
All right, thanks, Rob. So I'm just going to switch us back over to the PowerPoint for a couple of slides, and then I will start talking about the image configuration editor. So I brought this slide back up again so that we can see that what Rob just went through was this top path. This image builder wizard goes straight to the image builder engine, and then from there to my device. But I have this other path, which is convergent with that. So I use image configuration editor, which I'm installing on a dev machine, and still deploying using the image builder engine. So I have the additional step of figuring out my hardware, which I'm going to use the Target Analyzer tool to generate a PMQ file, which, as Rob talked about, enumerates all the devices on that hardware. And then I can feed that into image configuration editor, figure out what drivers I need. The output of image configuration editor is an XML file, which represents all of the packages and any custom applications or drivers I want to include. And then I feed that to IBW, either through USB, or I can create an IBW disk that's specific for that image. And I'll show you some of that as I go through my demo of ICE. So you want to go ahead and hit the next slide? So Image Configuration Editor enables build through the image builder engine. It gives you a set of advanced functionality like configuration of settings, so I can do things like turn the firewall on and off, set my partitioning up, things like that, all from my dev machine. So I have this large step of configuration in ICE. From there, I'm going to go to my answer file as my output, and then install with the image builder engine. So what we're going to learn today is we're going to learn how to do the same things that Rob just showed in his demo of IBW. Going to do a quick overview of how to do that in ICE, then move on to most advanced scenarios like configuring settings, getting my third-party applications working through ICE, and then how do I share that work with other developers, and then how do I deploy with that image. So with that, let's go ahead and switch to my laptop, which I've got ICE running on it. So first, I'm going to do a quick overview of what we're seeing here in Image Configuration Editor. If you're familiar with the Windows deployment tool WSIM, the Windows System Image Manager, ICE is based on that tool, and so this should look fairly familiar, but we've added a lot of extra features. So the pane on the left is my distribution share. This is a repository of everything that I have available to me to choose from. So I have my packages expanded. I have feature packages, language packs, drivers. I have updates. I have some security updates from Microsoft in my distribution share. And so I can pick from all of those to install on my device. I also have OEM folders, which are the mechanism for delivering custom files, so my third-party applications to my device. And I'll talk about that a bit more later. And I also have out-of-box drivers, which are the same thing Rod talked about earlier with adding extra drivers in IBW. The answer file, which is in the middle there, is what I described earlier as the representation of my image. So you can see right now I have the Windows Embedded Edition package in my answer file, and that is the embedded core that Rob mentioned earlier. So this is boot critical drivers. This is the minimum set of functionality that I need in order to get a standard 2011 image to work. And as you can see, I've got estimated footprint on the bottom for whichever packages I have included in there. On the right side, I have settings. That pane is dependent on what my focus is on. So right now I'm seeing all of the settings that I can configure through the embedded core. And I'll touch on those a bit later. And then at the bottom, I have a standard messages pane that tells me if I have problems with dependencies, if my XML is invalid for one reason or another. So let's start out by adding some feature packages. Rob, you can just go through and add some things that are interesting to you, like Internet Explorer. You need to go check Facebook and stuff on your embedded device. And we'll go ahead and validate with just a couple packages in there. Validate only. So we can see that we have multiple options here. We have add required packages and add required and optional packages, which were the same options we had in IBW. But ICE gives me the added control of being able to see exactly what packages are being brought into my image. And so I want to see that. So I'm going to look at validate only. So when we select that, you can see no additional packages came into my answer file, but I have a set of errors and warnings, and then an informational message on the bottom telling me about things I need to do in order to get my device working properly. So if you just select one of those error messages, you can see I have a set of packages that I need to include in order to get the embedded core to work properly. So I need first a boot environment. This is required. I need to pick between the standard Windows boot environment, or the enhanced write filter has its own boot environment, and the two are mutually exclusive. So I must pick one and only one, and so I'm required to satisfy this dependency. So on and so forth. I have branding. I have to pick whether I just want a command shell or the Windows shell. I have to choose whether I want the standard USB stack or if I want the USB boot embedded enabling feature, and I can select one or more language packs at this point. So let's just hit OK. And if we validate again, we'll see that that error message goes away, and then I simply have a set of remaining ones. I had a warning informing me that I didn't have a language pack. You must have a language pack to deploy. I can either build a new image or build a servicing configuration set, and a configuration set is something I'll talk on later, but it's basically a minimal set of functionality for a particular scenario. So if I want to deploy a particular image or I want to service my device, I can create a configuration set which will only contain the specific features that I need to do that. So that pretty much covers packages and dependencies. So the next thing I'm going to want to do is get hardware support for my device. So I can do that in a couple different ways. The way I'm going to show is if I go into File and then Import, I have the option to import a PMQ file. So if we select that, and you go to my desktop actually, I have gone ahead and gotten a devices.pmq file for, this one's actually for my laptop since we're running on the same set of hardware here. So if we go ahead and hit OK, or Open, what that'll do is automatically add the driver packages to my answer file that map to my set of hardware. Now, both IBW and ICE have various options. IBW lets you navigate to another driver inf file that can allow me to get some additional support that is not in the distribution share. But some of these warnings, if you look through them, are actually things that are in my distribution share. So I have things like networking drivers that don't get mapped to driver packages because they're actually in a feature pack. So I saw you scroll by one of those. You've got netrasa.inf down there. So what I can actually do is I can just search the distribution share very quickly to see if that is some package that I have available. So if I just open up Find, hit Control F to open up Find, and then search for file names and packages, I can search for that inf name just to make sure that it's not in a feature pack somewhere that I've missed. So if we go ahead and search for that, you can see pretty much immediately that search has found that I have a feature pack that contains that driver, and it's also picking up that I have several language packs that contain the language resources for that. So let's go ahead and double click on that, and that will navigate to it in my distribution share, and from there I can just add it to my device. So up until this point, we've covered pretty much only things that I could do in IBW. So let's move on to something that's specific to ICE. So if I go back down in my answer file pane and select the embedded core package, I can look at all of the settings that I can control through ICE. So if you want to scroll, it's all the way at the bottom there, and select that. You can see that I have a number of settings that I can influence. So before I talk about settings, I'm going to have to talk about the idea of passes. So if you select the filter view, you'll see that I have 7 passes or phases of Windows setup. So as I go through Windows setup, these will go through in series and process one pass at a time. So some of these passes may not occur. Obviously, the audit system and audit user passes won't happen unless you are booting into audit mode. Likewise, the generalized pass won't happen unless you're using sysprep, which you can do with image configuration editor. You can set sysprep commands. But the other passes are going to happen for every device. So I like to, when I work in ICE, work in a series of passes. So pass 1, Windows PE, is going to be my IBW environment. So I can affect things like IBW screens and my partitioning while I'm in pass 1. So if we filter on pass 1, I can see a set of commands that I can influence here. So if I'm doing all this configuration in ICE, I really don't want to see IBW. I want to have a completely unattended install so that when I install, all I have to do is provide my answer file, and I'm done. I have to do no more further work at build time. So if I scroll up and down through here, I have settings like I can accept the EULA somewhere in here. So I think that's towards the bottom in user data. Yep, there it is. So I can accept the EULA, and this bypasses the EULA screen in IBW. So this saves me a little bit of trouble when I'm deploying my image. I don't have to worry about one additional button to click. Now, I could go through and individually set each setting that I have done to completely suppress IBW. But I actually have a template that will do this for me. So if I look at my distribution share in the templates node, I've gone ahead and created a fully unattended template. So this is an answer file that contains all of the settings to suppress both UBI, the out-of-box experience, or Windows Welcome, as it's also called, and IBW. So if I include that template in my image, I only had to do the work once to get all of these settings done, It's very much like a macro component was if you're familiar with XP embedded. So let's just add that to my answer file and then take a look at the embedded core. And you can see I have things set up like my disk configuration. I've specified what disk and partition. I've specified the fact that I want to deploy in English, and so on and so forth. So I should also add here that there are a lot of people that aren't really familiar with our product. If I'm going too fast, if I'm going too slow, please feel free to interrupt me and ask questions. So if anybody's got a question here about IBW or ICE, why don't we go ahead and give you a chance to ask those? And I get silence. OK, let's keep going then. So the next thing I'm going to want to do is install my own custom applications on my target device. And the way I'm going to want to do that is with the OEM folder. So if I scroll up and expand my OEM folders node, you can see I have a folder for Silverlight. And so if you look into this folder, what it contains is the Silverlight installer. And so what I've done is, ahead of time, if you click Explore from here, you can see I have this folder. If you back up a step, you can see that I have this one subfolder, which is an escape sequence, so that when I install Windows Setup, we'll see, OK, this is an escape sequence to deliver all of the files underneath to my system drive environment variable, which is C the vast majority of the time. So if you look in there, I have the Silverlight installer. So all I need to do is include this folder to get the Silverlight installer delivered on my targeted device. So if we close out of that, go back to ICE, we can go ahead and right-click and then add that to our answer file. But we're not quite done yet. What we're going to have to also do is figure out what packages have binaries that Silverlight is dependent on. So it's probably not sufficient for me to just assume that everything Silverlight needs is in the embedded core. So what I'm going to have to do is run some dependency analysis. There are tools like Procmon, which you can use dynamic dependency analysis. So as the application is running, it will see what binaries are being touched and keep track of those. But we have a static dependency analyzer tool that, Rob, you want to go ahead and open that up? The static dependency analyzer. And so what I can do is I can point to a binary or set of binaries and then use that to determine all of the static dependencies that I can find. So I can just click. I've copied my installed directory of Microsoft Silverlight on my machine, on a Windows 7 machine, so that I can just look at them all at once. So if you want to back out and then just hit Open Folder, that will analyze all of the binaries that are in an installed Silverlight application. And it will bring up a summary of what packages those binaries are in my distribution share. So you can see I have a number of them. I have .NET 2.0 that's already in my answer file. And you can see that there's that one binary in that package that's being used by the set of packages, or the set of binaries that are in that bottom dropdown there. I also can see that I have an optional package, an update package, that is not in my distribution share. So it looks like a binary that Silverlight uses was updated. So let's go ahead and include that update package as well. So I have an option at the bottom that I can automatically create an OEM folder from these files. I don't want to do this in this case because I already went ahead and did it on my own. But if I run this on an installer, what I can do is do static dependency analysis of the installer, automatically add it into my distribution share, and then automatically add a command to enter that into my answer file, all from this one tool. So let's go ahead and hit OK. This is a good time for me to talk about update packages since I added one. Each update package contains parenting information regarding what packages it affects. So if I go back into my validate menu, you can see I have an add applicable updates option. So what this will do is it'll examine all of the updates I have in my distribution share and add any of them to which are applicable to my answer file. So let's go ahead and hit that. And you can see I have a number of update packages that get added as well. All right. Does anyone have any questions now? I mean, we're going pretty quick through this, and there's a lot of material, so feel free to speak up if you are curious about anything here. Yes?
What happens if you have dependencies between external packages?
Excuse me?
What happens if you have dependencies, meaning that you cannot install Office before installing something else?
Mm-hmm.
How do you control the flow of the installation itself?
Okay, so that's a great question. That leads me into the next thing I was going to talk about, actually. So let's talk about synchronous commands. So synchronous commands are commands that I can run. Essentially, they're commands from the command prompt that I can run at various stages during Windows setup. So if I go into the Insert menu, I can insert a synchronous command. And then I can control at what point I want this command to run. So I want, in this particular case, this command to run right at the end of setup. So I'm going to run it during the UBI pass. So if we select pass 7, I can enter a command from here. So what I want to do is execute the Silverlight installer. So if I do c:/silverlight.exe, then that will run that command at the UBI pass during setup. So if we look at that, we have the command, and it has an order as well. So if I have commands that I want to run in a specific order, I can just simply increment the order as needed to get them to run in a specific way. So I hope that answers your question. All right, thank you. Okay, so at this point, I've pretty much done all of the work that I want to do regarding my Silverlight application. So I've gone ahead and created a Silverlight template that you can see in my distribution share. Now, I can deploy using this template, or what I could do is maybe I'm working on a team with some other developers, and I want to share this work with them. My job is just to get Silverlight working, and their job is various other applications. So what I can do is I can export this template. If I right-click on it, I have an export template option. And so what this will do is it will export both the answer file and all custom resources that are used by that template to some location. And then what my teammate can do is then import that back into their distribution share. So it's a very quick, very easy way for me to get my work to another machine without worrying about having to redo that work among multiple people. So if we export that and open that directory, you can see I have my answer file there, and then I should have my Silverlight installer down in there as well. So the last thing I'm going to talk about is deploying an image. So I've been working on my development machine for some time now, and I want to actually put this on a device out in the field. So I have a couple options for that. I mentioned before the idea of the configuration set, which contains only the packages and custom files I need for my answer file that I currently have open. What I also have is a set of media creation options. So if you look down in that menu, I have one option that I use all the time. I love it. It's creating an IBW disk from the answer file. So what this does is it copies both the IBW binaries and a configuration set to a target location. And what that allows me to do is create this disk meant specifically for deploying this device that I have to have no further input for. All I need to do is boot from that disk, and IBW will start to run, consume that answer file, and deploy using that particular device. So that is pretty much the end of my ICE presentation. We went pretty quick through all of this. So let's go back to PowerPoint, and then we have...
Sure, questions?
Yes. Yes, so the distribution share is a file-based container, so any source control that you can use on your file-based system. But there is not one integrated in ICE, if that's what you're asking. Okay, yes.
Yes.
What about the product key or license key?
So yes, there is actually a setting that allows me to input my product key directly to the answer file. If you're asking about general, more how does licensing work, we have from our marketing team, Kong in the back there is actually a better person to ask about that than me. But I can actually input my product key from ICE.
Yeah, it's right here.
Yep. All right.
Any other questions? Nothing at all. Sweet.
All right, well, I guess we're great, and we really have nothing further to improve on if you don't have any questions about it.
So yeah, like we mentioned, our beta is available now. You can go to windowsembedded.com and check it out. Yes?
Question regarding deployment after the beta is ending, look at movies. Usually Windows 7 require activation and all that stuff. Most of the devices we're going to deploy to might not even have an internet connectivity. So we won't go one by one and activate them manually.
Right.
What type of activation support would be?
Kong, can you answer that? Nope. So I know we do have, believe it's called OEM activation, and it is much simpler. We've had lots of complaints in the past about activation, and we've tried greatly to improve it for Win 7 embedded. If you want to give me your card, or I can give you my card, and we can follow up and give you the exact details.
I can add to that, if you're familiar with our previous product activation scheme, this can be very similar to that. So there's no download code, there's no,
Both the bottom in the right place, way ahead.
you wouldn't have to do that.
Yes? The memory requirements, so the minimum footprint disk space for Windows 7 embedded is about 500 megabytes. That's disk space. And then our recommended RAM requirements are about 512 megabytes. You can probably get lower than that, but that's what we're advertising. The Windows embedded CE, Kong, do you know the extra?
Right, so the compact framework is only for CE, that's not really, that's not the standard for the compact.
All right, so, got one more question over here.
So we do have it's a full support for XPerf. Like you know, it's just a componentized version of Windows. So anything you can run on Windows 7, you should be able to run on this. I know we have a performance guy, and he runs XPerf all the time to try to get our boot time as quick as possible.
This also heavily warnings resume.
Yeah, there is. If you're familiar with our XP embedded product, we have a feature called Hibernates Once Resume Mini. So you can essentially just hibernate once and then boot up real quick.
But if you're more interested in performance, you should, I can give you my contact information and then put you in touch with the performance guy on our team. All right, thank you. All right, so please fill out some session evaluation forms. I'm sure you've heard this spiel a couple times before. And if you have any additional questions, we'll be hanging around. So thank you for your time.